Yes, learners. In the previous lesson, we spoke about the x coordinates of the turning point, and then we went ahead to find the first derivative of the equation or the function to determine the derivative, and we equated it to 0 so we could have the results like the x coordinates of the turning point. In this case now, we are done with that lesson. In our new lesson, we want to look at the same equation or the same function but determining the second derivative. As you can see, this was the first derivative we got in the earlier lesson, the previous lesson. So now we are at the second stage where we want to find the second derivative of that first derivative, of second derivative of the original equation. Now, so we don't have to leave one prime here. It has to be prime because it's a second derivative. Now, what we need to do is to consider the first derivative and derive it again to form the second one. So 2 times negative 3 will give us negative 6x. The power 2 minus 1 will give us power 1. So it means x has the power of 1, no longer 2. Now, x has the power of 1. If we multiply by 2, we will get positive 2. But if we subtract 1 from 1, it gives us 0. And so x has the power of 0. If x has the power of 0, it means the whole result here is 1. 1 times 2 is 2. This is a constant. So the first derivative of a constant is 0. So that's gone. But for us to look at the x coordinate of the point of inflection, we need to say our second derivative is equal to 0. So what is our second derivative? Our second derivative is minus 6x plus 2. So if our second derivative is the same as minus 6x plus 2, then we can equally say that then it is also equal to 0. If this is equal to 0, then this is also equal to 0. So what do we do? All we have to do is to say we need to find the inverse operation of plus 2. The inverse operation of plus 2 is minus 2, meaning we are subtracting 2 from both sides of the equation. If we subtract 2 here, the whole of this becomes 0. But if we subtract 2 from 0 here, it will give us negative 2. So we have minus 6x is equal to negative 2. Now, minus 6 is multiplying x. And so the inverse operation of minus 6 times x. So we are saying this is a product here. So minus 6 times x. So the inverse operation will be all divided by minus 6. We are dividing both sides of the equation now by minus 6 or negative 6. So it becomes x is equal to negative 2 divided by negative 6. So negative divided by negative is positive. 2 goes into itself once, and 2 goes into 6 thrice or 3 times. So now you can see clearly that this x is equal to 3 is the x coordinate of the point of inflection. Remember, for a cubic graph, we are supposed to have only one point of inflection, but we are supposed to have 2 turning points. So take note of that. So since we are going to have only one point of inflection, we can only have one x coordinate of the point of inflection. So this is what we've gotten to. In our next lesson, we can look at how to determine the y coordinates of the turning points of the cubic graph, and also the y coordinates of the point of inflection, because a point is not made up of only one coordinate, for example like x coordinate or y coordinate. A point is made up of 2 coordinates, which are x and y. So if you have to determine the coordinates of a point, then you are basically going to find both x and y coordinates. It depends on what the question says. Thank you.